We've all been promised these incredible AI assistants that really get us. But let's be honest, most of the time they feel like they have total amnesia. Well, today we're looking at a new framework called Maple that might just be the cure, promising an AI that finally actually remembers you.
So picture this. We got Sarah, a senior machine learning engineer, and Marcus, who's a new product manager. They both ask their company's AI the exact same question. What's a transformer in AI? And what do they get? The exact same one-size-fits-none answer. Sarah's frustrated because she wanted code details. Marcus is just lost in all the jargon. The AI completely failed both of them.
And here's the part that'll make you want to tear your hair out. The system knew Sarah loves technical deep dives and code examples. It knew Marcus learns best with simple analogies. All that data from their past conversations was right there, stored away. The system just ignored it.
Which brings us to the big question, right? Why does this keep happening? Well, the folks behind the Maple framework say it's not a memory problem at all. It's an architecture problem. We've been thinking about this the wrong way from the very beginning.
Now, this is where it gets really interesting. The core idea behind Maple is that what we call memory isn't one single thing. Nope, it's actually three totally separate capabilities that we've been mistakenly lumping together. Let's break those down.
So first up, you've got memory itself. And you should just think of this as a giant warehouse. It's just the storage space. It holds all the raw data. Every chat, every piece of feedback, every preference you've ever mentioned, it just sits there waiting.
Next, we have learning. This is like the smart curator of that warehouse. It's the intelligence that works quietly in the background, sifting through all that data to find the important patterns. This is the part that figures out, hey, Sarah always clicks on the code examples, or Marcus seems to really get these analogies. And finally, we have personalization. This is your personal shopper. When you ask a question, this is the agent that sprints over to the curator, grabs the file of insights about you, and uses it in that moment to custom build a response that's perfect for you.
I love this analogy because it just makes so much sense. The warehouse stores everything, the curator figures out what's important, and the shopper grabs exactly what you need right when you need it. When you separate these jobs, the whole system becomes exponentially smarter.
So the billion-dollar question is, how do you actually build this separation into a system's DNA? Well, that's exactly what Maple is. It's an architecture designed from the ground up to treat these three components as their own distinct but coordinated agents. So here's how it plays out in real time. You ask a question. Instantly, the personalization agent zips over to memory and grabs what it knows about you. The main agent uses that context to give you a perfectly tailored answer. And then, and this is the genius part, after you have your answer, the learning agent gets to work in the background, analyzing that whole interaction to make your profile even richer for next time.
And this diagram really shows you the secret sauce. See, your request is in the fast lane. It gets a personalized response lickety-split. The deep thinking, the part where the system actually gets smarter about you, that happens completely in the background, asynchronously. This is the key. The AI is constantly improving without ever making you wait. And here's the proof in the pudding. On the left, that's the generic junk Sarah and Marcus got before. But with Maple, Sarah gets a straight-up PyTorch code snippet, exactly what she needed. And Marcus gets this great analogy he can actually use. It's the same question, but the architecture delivers two wildly different and infinitely more helpful answers.
Okay, that all sounds fantastic in theory. But does this architectural shift actually deliver, when the rubber meets the road? Well, the researchers pitted Maple against a standard, stateless AI to find out.
And wow, the results are pretty stark. Just look at this. The old school AI, it only managed to use what it knew about the user less than half the time. But Maple, it nailed it, incorporating user traits in 75% of its answers. That's a massive leap. And it's not just that. A human judge also rated Maple's overall answers as being significantly better. Let's just zero in on that quality score for a second. We're talking a 14.6% jump. Now, in the world of AI benchmarks, that's not just a little bump, that is huge. This isn't some minor tweak. It's proof that changing the core architecture delivers a major, meaningful leap in performance. So how does it pull this off? Well, it's not about remembering just one little fact. Maple wins because it can synthesize multiple things about you. It understands you live in the city with kids and a dog, and connects that to a suggestion for durable furniture. It anticipates needs you didn't even state, like recommending an ergonomic chair because it remembers you mentioned a bad back months ago. It just stops asking you questions it should already know the answer to.
So let's zoom out for a second. Why is this so important? What does this mean for the future of AI? Well, it's about fundamentally changing how we approach building these intelligent systems.
You know, a common idea right now is to just make the AI's short-term memory, its context window, bigger and bigger. But that's a dead end. You just end up with what the paper calls context rot, where old, irrelevant info clogs everything up. Maple's approach is completely different. The goal isn't bigger memory, it's smarter memory.
So, I'll just leave you with this thought. Imagine an AI that doesn't just respond to you, but anticipates you. An assistant that understands your goals, your style, your whole context. What could you create, what problems could you solve if your AI truly, deeply, actually knew you?